Hey, sixth graders, Mr. Ronan here. I have another presentation for you guys to watch, this time for math. And what we're going to go over today is finding the area of parallelograms. And this is something we've been talking about. We talked about today in class, and over the last several days, we've been talking about finding the area of various shapes. But today we're going to key in on parallelograms and applying the formula to how to find the area of a parallelogram. So first off, we're finding the area of a parallelogram. It's important to understand what a parallelogram is. So a parallelogram is a shape that has four sides. So a parallelogram cannot have three sides, it cannot have five sides, otherwise it will not be a parallelogram. It has to have four sides. What we have to notice is we're going to look at the opposite sides. So the opposite sides of a parallelogram, and I want you to notice, follow my mouse if you would. So here's one side. Its opposite side would be down here. Opposite sides are the sides that are directly across from it. This side right here is adjacent to this side. It's not opposite, it's adjacent. These two sides would be opposite. I hope that's clear. So opposite sides are parallel, meaning if they were to continue going up and down, and if these sides would never end, that means they would never cross. So if we look at the opposite sides on this shape right here, on this rectangle, the opposite sides, if the lines were to continue going, they would never cross. They would never meet each other. We also have to realize opposite sides are parallel and they have an equal length. This is going to be huge. It's so important that we remember this, that not only are the opposite sides parallel, but they also have an equal length. Just using the eye test, we can easily prove that this side right here and its opposite side have the same length. Same with the sides right here. This side easily can be proven that it has an equal length with this side right here, just based on the eye test. And I threw an example in right here. You say, Mr. Ronan, is this trapezoid a parallelogram? Absolutely not. So, if I'm looking at it, I see, okay, there's one side, two sides, three sides, four sides. Boom! It takes the checkpoint right there. Four sides. Let's look at the second bullet point. Are the opposite sides parallel? Well, this side and this side, they'll never cross if they were to keep going. But right off the bat, I noticed that these sides are not equal. This side is so much smaller than this side. And let's also look at the sides on the left and right of this trapezoid. If these lines were to extend and to keep on going, it's pretty clear that they would eventually cross. So they're not parallel. This shape, this red shape, is not a parallelogram. I just threw that in to show an example of what a parallelogram does not look like. All right, so now that we have that established, it's important. What is area? If we're trying to find the area of parallelograms, and we know what a parallelogram is, but what is area? An area is the amount of space an object takes up. So if we look at this rectangle right here, this blue rectangle, we would try to, and we wanted to know the area of this shape, we would simply count the boxes to figure out how many boxes are taken up by this shape. So I'll save you the math, I'll save you the counting. There are 24 boxes that are being covered, 24 boxes that are shaded in, rather. So the area of this shape right here is 24 units squared. It's going to be important that we're going to square our units when we find area. So now that we know what area is and what a parallelogram is, we're going to tie it all together. What is the formula to find the area of a parallelogram? That's what you all came here for, and I'm going to give it to you. In order to find area, we're going to multiply the base of our shape, or of our parallelogram rather, by the height of the parallelogram. So this formula, if we multiply our base and our height, this will give us the area every single time for a parallelogram. It's so important to remember that this is just for a parallelogram, because if we're trying to find the area of a triangle, that formula is going to be a bit different. Very different. I should have said very different, not a bit. And it's important that we recognize that this formula is for parallelograms only. So right now you guys are being a little testy with me. You're saying, prove it, Mr. Ronan. Prove to me that this formula will give me the area of parallelograms. Fine. I will prove that to you since you asked so nicely. We're going to go back here a little bit. I know we just saw this slide. I'm going to go over it again. So we already talked about, if you want to pause it right now and count how many boxes are shaded in, I'll tell you right now that 24 boxes are shaded in. If you don't believe me, you can pause it, count them yourself, or you can take my word for it. So if we count each individual box, you'll get 24. And I told you the formula was, in order to find the area of a parallelogram, right here we have a parallelogram, right? We have four sides, opposite sides are parallel and equal, right? If we look, 1, 2, 3, 4, 5, 6 units, 1, 2, 3, 4, 5, 6 units, right? So the opposite sides are parallel and equal. There are 24 boxes shaded in, and I told you the formula to find the area of a parallelogram is base times height, right? Area equals base times height. So let's say 4 is our base. Right down here, I'm getting 4 because we have 1 box, 2 boxes, 3 boxes, 4 boxes. And our height goes straight up and down. Height is 6 boxes. 1, 2, 3, 4, 5, 6. So in order to find the area of the shape, we're going to multiply those two numbers because 4 is our base, 6 is our height. 4 times 6 equals 24. Okay, and how many boxes did I just say were shaded in? 24. So if we multiply our base by our height, that will give us the area every single time for a parallelogram. I hope you believe me now. And it's important to remember that height goes straight up and down. This will be super vital as we move on in the slideshow here in a little bit. But I want you to recognize that height goes straight up and down. And I want you to think about when you go to the doctor or whenever you get your height measured. Are you looking like this guy who's working out? We'll call him Jeff. Are you looking like Jeff when he's stretching? Or are you looking like Jeff when he's standing straight up? Your doctor will not take your height if you're standing like this. Your doctor will ask you to stand up straight like Jeff is in this first picture right here. So height is measured from top to bottom. You have to be straight. Otherwise, it does not tell us what your height is. If you're bent over, if you're not standing straight, or if you're slanted, height is straight up. So we're going to try a problem real quick. You guys might remember this one from class. You're probably saying, Mr. Ronan, why are we doing the same exact problem we did in class? This is ridiculous. Well, this is a great example, and it starts off pretty simple. And first thing we recognize is this is a great example of a parallelogram. We see that the opposite sides are parallel. They will never cross. We see that there are 4 sides here. And just using the eye test, we can identify that these two sides are equal. Opposite sides are equal, rather. So if you remember what our formula is to find the area of a parallelogram, it would be our base times our height. Now, I want you to look at this. We have our base is 10, and our height goes straight up and down. We have 6. This dotted line right here is not part of the shape. This doesn't mean we have a trapezoid right here and then a triangle right here. No, this is one parallelogram. This dotted line is just to indicate to us that 6 centimeters is our height. Because notice how this dotted line goes straight up and down. Close this. Straight up and down. So first thing we have to recognize, what is our base? Our base is 10 centimeters. What's our height? Height goes straight up and down. That is 6 centimeters. So to find our area, we'll go multiply our base times our height. So our base is 10 centimeters. Our height is 6 centimeters. What is 10 times 6? That is 60. So our area would be 60 centimeters cubed, right? Because we are, oops, what did I do? Oh my goodness. What happened here? I'm on the wrong slideshow now, guys. All right, that's better. So we always, when we're finding the area, we're going to square our unit. Right now our unit is centimeters, so it would be centimeters squared. You know, I should have wrote that down on this. I'm sorry. You guys saw it in class, so hopefully you remember. It should be in your notes. So we'll multiply 10 times 6, we'll get 6 centimeters squared. My question is, we use 10 as our base in this in the formula, and we said 6 was our height. Would the answer be different if 6 was our base and we said 10 was our height? No, 6 times 10 is the same as 10 times 6. We get the same exact answer. So whether you choose 6 as your base or as your height, doesn't necessarily matter. You'll get the same answer regardless. And I also want you to realize something real quick before I move on to the next slide, because this is extremely important. When I'm having you guys find the area of a parallelogram, I want your eyes to immediately go to this little box right here. This little box, if you follow my arrow. And I hope the arrow is showing up, by the way. Otherwise, none of this will be making any sense when I say follow the area. So I might have to edit this video if it doesn't show up. So I'm hoping it works. So I want our eyes to go immediately to this little box. This is called a right angle. And this tells us that this dotted line right here and this solid line right here are perpendicular, meaning that this line has a 90-degree angle with this line with this side right here. In other words, this line is flat. It's like the ground. Let's say you're at the doctor. You're standing on the ground, which would be represented by this side that's called 10 centimeters. And you would be represented by this dotted line because you're standing straight up. And that's what this little box tells us. It tells us that this line is straight. It is going straight up. So that means we can use that as the height. So when we're finding our base and our height have to be connected to this box. Notice how this side right here isn't connected to this box. Notice how this side right here is not connected to this box. What is? The 10 centimeters, the line that's called 10 centimeters is touching this box, and the line that's called 6 centimeters is touching this box. That means whatever lines are touching this box are the two numbers we're going to multiply together to find the area. And that'll be really important once you get to this next one right here. So right off the bat, we have a few problems. When we're finding the area of a parallelogram, we multiply base times our height. That's 2 measurements. This shape right here, we have 3 measurements. So we have some thinking to do here. Some thinking. First thing, like I said with that last problem, is that we want to identify where that right angle is, that little box, and whatever lines or whatever sides are making contact with that box, those are the measurements that we're going to multiply together to find the area of our parallelogram. So that means 8 is out of the question, because this side right here, side that's 8 centimeters long, this one, follow my mouse, this is not touching this box right here. It's not touching this box. It's not even close. So that's 8 is out of the question, or out of the picture, I should say. So now we're left with 9 centimeters and 7 centimeters. Now I see that this dotted line called 7 centimeters is touching this box. Notice how this line connects right at that box right there. So that means we're going to be using 7 centimeters in our equation. However, we don't know the length of this side right here. How on earth are we going to find that out? Well, if you remember that this is a parallelogram, and we know that the opposite sides of a parallelogram have the same measurement. So we know if this side is 9 centimeters, this side must be 9 centimeters as well. Okay? So we know this side is 9 centimeters, this side, or this measurement is 7 centimeters, and they're both making contact with the box. We're going to multiply those two numbers together. So we multiply 9 times 7, and we'll get 63 centimeters squared. 63 centimeters squared, and that would be the area of this shape right here. Okay? I hope this might clear some things up. If you're still not sure about something that I talked about in this video, I'll see you in class tomorrow, or whenever you see this, whenever you decide to watch this video. You go ahead and give me a shout tomorrow morning, or maybe during study hall or intervention time, and I'll try to clear up any questions that we still have. But yeah, I'm so grateful that you watched this video. This should not be here. Sorry. Don't save. And yeah, have a good rest of your day. Thanks, 6th graders.